Hello and welcome to 5.7 Meat Production Methods. This will be probably of this entire chapter 5, the most important and the most asked about of the entire unit 5. So we're going to pay careful attention to a lot of things here because this particular unit or this particular section brings in a lot of the other areas of this course. So we're going to see a lot of other things brought in. So first order of business, let's look at the learning objectives. And we're going to talk about methods of meat production. And that's going to include chicken and beef and other things that we eat. There are going to be benefits and there are going to be drawbacks of each of these methods. We'll look at those. And also, this is a big kind of, shorthand abbreviation thing. CAFO is called a concentrated animal feeding operation. And we're going to talk a lot about that and how that's the exact opposite of what is known as free range. We're going to talk about the efficiency of meat. We're going to talk about how these CAFOs, once again, are good and that they are bad. Introduce the word feedlot to you, and get into how free-range grazing also has benefits and drawbacks, so you have to be careful on that. One of the major drawbacks being something called overgrazing, which we'll talk about, because if you let the animals eat too much, then you're going to be down to dirt, and a lot of the times these grazing operations are not in the most rain-prone areas, so they have to be careful on that. And it may lead to desertification. And finally, if we consume less meat, and again, this is not a plea to become a vegetarian. That's not what this chapter is about, and that's not what I'm about. But in just reducing our amount of meat consumed, we don't have to bring it to zero, we're going to see there's going to be a major reduction in these gases, which would be carbon dioxide, methane, and nitrous oxide, all of which are greenhouse gases, which we'll talk a little bit about. And we're going to conserve water, and we're going to limit antibiotics. So once again, this is a huge chapter with huge implications in this class. So let's begin. CAFOs, if you look at this picture, this C stands for concentrated, and you can see a lot of cows. A for animal, farm for farming, O for operations. There are a lot of, in this particular case, cows in a very small area. And this probably isn't even nearly as bad as it could be. So this is bad, but it could be much worse. A lot of costs, a lot of benefits. But one of the benefits which we're going to see is all about the mighty dollar. How much can the consumer save? But we'll get into that. Let's talk about the benefits. We'll start with those. Also called feedlots, these are extremely densely crowded. And again, if you've seen some of these videos on the way that they raise chickens, that would be, again, a very concentrated method of raising animals. It's not very humane, but again, it keeps the costs down. Here, in many of them, they are fed corn. And again, corn has a lot of calories. Corn is very easy to grow, and we grow a lot of it in America. And it will help these animals gain weight very, very quickly, making them able to become burgers or chicken cutlets. There's that same picture again. What it does is it maximizes land use and profit, meaning a lot of animals, not a lot of land. It minimizes the cost. As we said earlier, it's all about the almighty dollar. If beef becomes, even regular hamburger, chopped meat becomes, whatever, $20 a pound or something like that. Places like McDonald's, they're not going to make it. Your average grocery store isn't going to make it. And it's just going to be impossible to feed your family at ground beef being $20 a pound. So the cost comes, unfortunately, at the cost of these animals. And this pops up a lot, and this is not really a benefit, but what happens here is there are large amounts of gases produced. Carbon dioxide, because these animals are breathing and they're doing respiration, which we talked about in the last chapter with the carbon cycle. They are, believe it or not, farting and pooping. Methane is released when they do that. And nitrous oxide, which we're going to talk about, that is also part of the nitrogen cycle, which when there's so much of this nitrogen in the ground, these denitrifying bacteria can actually return it to the atmosphere. So kind of this chapter brings in a lot of what we've been speaking about. And these things will lead to climate change, which we will talk a lot about in this class moving forward. Costs. Well, again, same picture, very disturbing. These animals must be given antibiotics. Now, we take antibiotics if we go to the doctor, if we're not feeling well for sore throats or strep throat or ear infections or things. But these animals need to be given antibiotics because when they're super crowded like that, the chance of any kind of bacterial infection running rampant is very high. And if one dies and this one gets sick and this one gets sick and this one gets sick, before you know it, you lost many cattle or chickens or whatever. And that's not going to be good, again, for the bottom line. And of course, you don't want the animals to die of a bacterial infection. That's horrible. They're also given growth hormones. Now, a lot of these companies on TV swear up and down that they're not giving the animals antibiotics and growth hormones, but you're looking at the size of these chicken breasts and they are absolutely humongous, and you're saying to yourself, how is that possible? And when I was in a place like Key West and there are chickens all over the place, they're not that big. So something seems a little fishy about that. But anyway, growth hormones will allow these animals to grow very, very, very quickly. And again, the faster they grow, the faster they can become packaged and eaten. They do produce a tremendous amount of waste. And we're going to talk about that. That's another big deal they like in this course. And this waste is either going to make its way to surface water, things like lakes and streams, or if it sinks down long enough, it will get into the groundwater. Both of those things, not good. And it produces large amounts of CO2, methane, and nitrous oxide. Once again, I don't know why I put that in the benefits section, but it's a cost, so that will be removed. This is an interesting thing. It's called the manure lagoon. Now, this is something that you don't think about as an average consumer, and I myself never gave it any thought before I started teaching this course. I never even thought about where the poop goes. But in these large operations, they have to get rid of that waste fast, because if they don't, these animals are going to be walking in it, and that could, again, contaminate the meat, so they got to get rid of it. So they are large open storage pits for this manure. Now, the manure contains ammonia, which has this N in it, which we learned all about. Eutrophication is coming up. The hormones that they were injected are going to leave through their feces. The antibiotics are going to leave through their feces. And this bad bacteria called E. coli. Well, there's a version of E. coli. There's lots of E. coli. The E is the genus. The E, some E. coli are beneficial, some are not. But the ones that are bad can make people or other animals very, very, very sick. So the E. coli is toxic to humans. That's what you would commonly know as food poisoning, which you will see a lot of times in outbreaks at like even lettuce plants, which I know sounds weird how there's E. coli outbreaks at a lettuce plant, but that could get people very sick. The nitrogen in the ammonia can lead to excess nitrogen getting into the system, causing eutrophication, which we, again, refresh our memory. Excess nutrients causes excess growth of algae or other plant materials. They will die. That decomposition, or the organisms that do the decomposing, require oxygen. They pull the dissolved oxygen out of the water. All the organisms suffer. Common theme throughout this course. And then these antibiotics and growth hormones, again, something you don't even think about. But if this gets into the water and then you consume it, it can mess up your endocrine system. And we're going to learn coming up in this course that it can mess up the endocrine systems of other organisms, especially the sex hormones, testosterone and estrogen. And by messing with those, certain populations only have one gender. And if there's only one gender, there can't be more babies. So this whole antibiotic growth hormone thing getting into the supply of water or into the ecosystem is very bad. And this is, in essence, what happens. The manure is collected in these pits, these lagoons. Now, the problem, this is an even larger scale one from far away, is this stinks. I mean, you have probably smelled manure when you've driven by a farm of any sort, if you've ever gone out east or anything like that, or upstate. And that's bad. And also, it's prone to, if it really, really, really rains, it's going to overflow out of the farmer's control. Now, assuming that rain and precipitation and everything stays normal, they control it. But if it rains too much, not good. So basically, all of this excess ammonia through denitrification, which we learned about in the last process, is going to release nitrogen into the air as N2O, or nitrous oxide, which is a gas. Very powerful greenhouse gas. They can be emptied and turned into fertilizer pellets. That's good. That's an excellent way to kind of reuse the manure. But again, heavy rain or any kind of flooding situation can definitely have all of this excess liquid, wet manure overflow and get into groundwater or surface waters. So again, not good, and it stinks. Free-range grazing. You probably have heard, we only use free-range chickens. We only use free-range cows or cattle or whatever animal you're raising. In theory, it is a brilliant idea. Awesome, even. But can it work? So if you're free-ranged according to the legit free-ranged rules, you graze on grass. You do not eat an excessive amount of corn. The animals grow at a natural rate, no growth hormones, and supposedly grass-fed cattle is way better quality, but everything costs money. Here, these cattle look extra happy. I do not see any kind of cages. I do not see any kind of factories here. I just see cows eating the grass, looking very, very happy. There's no need for antibiotics because these particular animals aren't really, they look a little close to each other right here, but for the most part, they're not stacked on top of each other. So if one gets sick, the farmer will notice it, take care of it, and it will not, get the other one sick. It does not require corn, which is great. The waste here, and again, this is interesting, if it's not concentrated and put into these nasty manure lagoons, it can be dispersed naturally. And in most animals, their waste, not humans, humans have a lot of other nasty toxic things in it, but a lot of animal waste is actually a really decent fertilizer as long as it's spread out or dispersed, so the rain can break it down, it could actually get brought back into the soil, and the levels of nitrogen aren't going to be super duper high, making this whole greenhouse gas a problem. Unfortunately, it does require a lot of land, which we talked about, for every pound of meat produced, which again is going to bring up the money. Super expensive. Be careful on that. And nice thing, most of the time, these free-range areas are in kind of low precipitation areas. So it's not land that is absolutely the most amazing land ever for farming. So it's nice. It kind of has like a double-edged good sword, I guess. Well, if you do let them eat too much, it will lead to something called overgrazing, where they can actually eat the grass down to the dirt. Again, not good. So too many animals in any given area of land will remove all of the vegetation. So if you look here, now this fence is here for a reason. So whatever was eating it, ate all of the vegetation. Now there's none. So in this situation, what I'm imagining is then they will bring the whole population to this side. They'll eat over there. This will grow back, hopefully when it rains. And they'll simply switch the animals back and forth. And that to me seems like a reasonable idea. In the event that there are too many animals walking at one time, they can actually do what's called compact the soil, which we will learn about later. And when dirt is packed down, it doesn't have the ability to hold water as well. And because it can't hold the water as well, when it does rain, it just literally runs off, leading to more erosion. And what could happen, and this is again strange, but if they eat too much and it doesn't rain, you're going to have what's called desertification. And this happens when the plants are killed by overgrazing and the soil is compacted. And when it rains, the water doesn't have a chance to sink in. Now, this diagram is kind of interesting. We're going to see it again in a little bit. That cutting it or letting it be grazed too quickly, you can see here, tiny roots. If you let it grow, you have deeper roots. But again, one of those things where if you wait too long, and the animals are hungry. If you let them graze too much, then there's no vegetation. So it's a constant battle with what to do. So they do what's called rotational grazing, very similar to what I showed you in that picture. This allows the animals to kind of move from one position to another. And this will allow the increase of growth, which is nice. And the manure gets distributed, it becomes a natural fertilizer, and this will help the grass grow quicker. Now, I thought this was also an interesting graph, that even on your own lawn, and I don't know how many of you actually mow your lawn, but if you cut it too often and too short, it might look nice, but it's not healthy, it's not good. If you let it grow crazy, then what it does is it kind of actually begins to seed at the end. And sometimes if you have a neighbor or something, or if you have not gotten to your grass for a while, you'll see this, in essence, looks like seeds at the end. And then the grass may actually die. So it's crazy. So there is this fine line of when to cut it and how low to cut it. And the grass will actually respond. And if you follow these rules, your grass will grow fairly well and fairly quickly. So farmers, of course, have figured this out. Meat inefficiency. You're like, what does that mean? Again, another theme that we're going to start discussing now, which is going to carry on for multiple chapters here. Producing meat for us to eat, it's yummy. Everyone's like, it's got so much protein, it's got this, it's got that, it's so great. But the problem is, in order to grow one cow, it requires a ridiculous amount of land and a ridiculous amount of water. Because remember, these animals have to drink, and these animals may live for many years before they become a hamburger. So about 20 times the amount of land is needed to produce the same amount of calories that a plant would. Now, they're different kind of calories, understood, but remember, we only have so much land. We only have so much water on this planet. So that's where the problem becomes here. So the energy, all of the energy needed to plant, grow, harvest plants to feed the animals, plus the water, and you have to house these animals because remember where they live. It might be cold in the wintertime. So this I thought was, again, an interesting graph. Things like plants, corns, apples, things like that. They do not take too much energy per pound in order to produce. But to produce beef, which takes over 30 kilowatt hours per pound. Now, again, you don't know what a kilowatt hour is, but you'll learn, and it's a unit of energy. Pork, pigs grow a little quicker. They're a little bit smaller, a little bit less energy per pound. But if you see, cheese is high because, remember, cheese comes from milk, which comes from cows. Chicken and eggs are similar because typically one chicken can lay many eggs, but you still have to keep that chicken alive. So it's very interesting how all of these kind of energy uses work. And you don't think about it until you see a chart like this. And then, of course, there's energy needed to slaughter the animal and to package it. And these processing plants are bigger than you can imagine. I mean, we don't have any here on Long Island, but if you go out to the Midwest, these things are humongous. Again, land takes a lot of land to feed, a lot of room. And if you look here, beef in what's called usable protein per acre, you're getting 20 out of beef. But something like soy, you're getting 356. There's your plants. If you notice, these are all your plants where you can get some protein out of those. Way, way, way more efficient. Water, all of the water for the crops that the animals, forget about the water that the animals are drinking. You have to water the crops of the plants the animals are eating. Once again, very, very, very inefficient. Oops, let's go to this. And you can see here, once again, the amount of water needed to produce just 1 gram of protein. You need, I believe this is in ounces, to get 1 gram of protein, you need 112 ounces of water for beef, 63, 57, 34 for all these animals. Coming down to vegetables, you can see these numbers are way smaller. So, just to give you an idea, a lot of water and a lot of land is needed. Well, let's finish it up. Practice FRQ. Yes, this was a long chapter. I'm actually going to give you 2 weeks for this one. I'm going to be nice. And the question, explain the environmental benefits of eating a plant-based diet rather than a meat-based diet, and use the data below. So again, this is one of those questions where it's a slight opinion with some fact, but do your best, and hopefully that was helpful.